let's start with the next talk. It's Introduction to Distributed Tracing by Suraj Nath. He's from Grafana Labs.
Cool. Yeah, I am Suraj. I work at a company called Grafana Labs. It's a company behind Grafana and many other open source projects. And I work on a distributed tracing storage project called Tempo there. Raise your hand if you have heard of distributed tracing. Raise your hand if you have used tracing in some way, like maybe once or twice. Raise your hand if you are using tracing almost every day or, like 2-3 times a week. Okay. Okay. And since this is DevOps days, raise your hand if you are operating any tracing database internally at your organization, something like Jaeger, Zipkin. Okay. So only one hand? 2, 3? Okay. Okay. So this talk is more around tracing 101, what is distributed tracing, basics of it, and how you can set up your own tracing system. So another question I want to ask is folks who raise their hand that they are using tracing every day. What are you using for distributed tracing? Raise your hand if you're using Jaeger. Okay, few hands. Zipkin folks. No Zipkin? Okay. Tempo, anyone using Tempo? No Tempo. Okay, cool. Anyone else using proprietary stuff like Datadog, New Relic? Okay, bunch of, okay. So this talk doesn't have anything about proprietary database. I'm only talking about open source stuff and what is out there in the open source world. So what is this screen? Who's familiar with something like this? Like this is from Go. You must have seen something like this in any other programming language that you're using, right? If we see this is a stack trace of a panic. Like you might see a stack trace in an error, and when you have a stack trace, what do you usually look for? Like most likely you're looking for line numbers. Like which file, which line, where my code is crashing. And if we remove all the extra stuff, this is mostly what you're looking for, right? And here you see, okay, page.go, data raider, and then like you are looking for the functions, you're looking for the files and stuff like that. And you basically manually build a trace in your head. Okay, this failed. This called this line, this called this line, this called this line, right? You build a mental model of that stack trace when you're debugging something, right? And another example of, like if you have done profiling or, you must have seen something like a call graph. And call graph is basically a graph of, like who's calling what and when, basically. I mean, there is no when component in this diagram. It's only showing who's calling what. This is an example diagram. This is not a real call graph. So if you know about call graph, distributed tracing is nothing but it's a call graph that goes across services. Like let's say you have 2, 3, 5, 10, 20, 50, however many services you have, and you want to know who's calling what. You reach out to distributed tracing. And it's pretty much that, like exactly not, I mean, obviously implementation details and whatnot differs, but think of it like a distributed call graph across your services. So before we jump deep into it, let's look at some terms that are out there. So the basic unit, where everything is stored in tracing is called a trace. So this is a screenshot of a trace. Here you see 2 different colors on the screen. And you see a timeline that goes from 0 to, like this direction. And the small chunks that you see, they are part of the whole trace. So the whole thing is a single trace. And the small individual chunks that you see, they're called spans. So trace is your end-to-end operation, basically. Let's say you made an HTTP request that went through 3 different services, came back and responded. So the whole thing will be recorded under uh, a single trace. And each service is doing its own operation, right? In this screenshot, you see that there is some operation that is going on, right? Check bloom function is being called. So any operation that you do inside your service, you instrument it as a span. Span is nothing but a function call, database call, any operation basically, a unit of work, if you think of it. And trace is a collection of spans. So then another important concept in tracing is called context propagation. Context propagation is important because this is how you build the cross-service traces, right? You see two different colors where two different services are connected. How do we know, who called what? So context propagation mostly done through headers or whatever way you're calling your services. You attach extra header information about root trace to the service that, like whatever spans you produce, they belong to this trace. And that service will generate those spans, attach that trace ID with those spans and send it back. And this is how the cross-service, like trace is built. So context propagation, again, this is a simplified diagram of what we saw before. Here, A, B, C, D, E, these are 5 different services. Time goes from this side to that side, and the whole thing is a trace, and what you see, these individual blocks, like different colored blocks, they are your spans. And here you see the very first request that hits your service, it generates a unique ID and puts that in a context. That unique ID is called trace ID. And then that context is basically that trace ID information is passed from, like when A is calling B and E, it's passing that context with the call. And then B takes that context and passes it along to C and D. So now every service will do its own operation, attach all the spans that it created, and say that they belong to that trace ID. And that's how we build this trace. So another question that comes in, like we already have logging, we already have metrics. I know my services are slow. I'll look at my Prometheus metrics, there will be a blip. And if I want to know about errors, I can grab through my logs, whatever logging method you're using. Why do I need tracing? Like why tracing is important. There are few things that tracing solves that are not, that are not easily solved by just metrics and logging. First one is modern web services are complex, every single service will have some sort of a cache. It will have its own databases. Then there is some sort of retry logic that is happening. And if you have a sizable number of services and a single call that goes through all of them, and in some cases, your calls will not be static, like depending on what user asked for, you'll go to different services. If user asked for something that is related to billing, you might go to billing service, If user is asking something about, let's say you are a logistic company, something about order tracking and whatnot. So you'll go to order tracking service. So depending on different pages, you might go to different services, and each service have its own complexity, own databases, own caches. It kind of goes out of hand, like everybody has their own endpoints, everybody is doing their own thing. So getting a single picture, what actually happened within a request, it's kind of hard. And tracing gives you that. Another one is logs and metrics, like you'll get what happened in one service in the logs of that service. What happened in the other service in the logs of the other service. Each service will have its own metrics. This service will tell, okay, I called service B was slow. Service B will say, I called service C is slow. Service C is calling some third party, and it will say it's slow. Then you need to correlate and find out, who's actual culprit, who's slow, And if that chain is bigger, and if it goes cross teams, then you have to talk to multiple human beings to figure it out, right? Because engineer who's working on service A might not know what metrics service B is producing or exporting, and how do I look at this, right? So tracing will give you a timeline, basically. It will tell, who called what, how much time they took. So it's really helpful to give you that single picture on who's the culprit basically in cases when you want to debug. So it's really handy in that scenario. Another neat use case that tracing solves is that you you might have some mysterious queries that are slow. Some queries are slow on Monday mornings, not in the afternoon, and there are some mysterious bugs that only happen in production. You cannot reproduce them. That's and those are the worst kind of bugs, right? You don't know how to fix them because you don't even know where it is happening. And if you have the complete picture, you'll be able to spot it. You'll be able to find it more easily because tracing captured that error when it happened. So you have that data. You can look at that. Like whatever failure happened, whatever bottleneck happened. Whatever. Like who was slow basically? You can ask that question if you have the tracing data. Another thing that tracing can be used to is performance optimization work, right? Like you have some code path that is slow. Only when somebody is querying it, some other user is querying it, it's fast for them, some other user slow. So these kind of scenarios are not easily debugged with logs and metrics. And tracing gives you that full picture. So now I've convinced all of you that you should do tracing. I'll come back to that, but you're asking, how do I do it? So there are easy 4 steps. Step 1 is you instrument your application. Your traces are only as good as your instrumentation. If your instrumentation is not good, like you're just saying HTTP request received, response sent, then your tracing information is as good as your log line. You're not attaching any extra information to it. So you need to instrument your application to get value out of your tracing setup. Some languages have auto instrumentation built in. For example, if you are using something like Ruby, Node, Java, there are SDKs that will do auto instrumentation for most popular frameworks, most popular databases. So you don't need to do all of it yourself, but you need to make sure that your instrumentation is there. You have enough instrumentation to get value out of it. Now you have instrumented your application. It is generating traces, it is generating spans. So what you usually do is your service will push those spans and traces to an agent or collector or pipeline or whatever you want to call it, like same, different names, same thing. It's basically something that is running in your infrastructure. All services are reporting your traces and spans to that collector. That collector, can do different things also. For example, if you're running in your in Cube, the collector might pull labels from Cube API and attach those labels to your traces. So you can do enrichment as well. You can do sampling. You can do filtering that, like, these are the traces that I want to send, these are the traces I want to drop and whatnot. And this is done close to your services. So you don't send out all the, data that you want to drop all the way to your database and then drop it, right? So it's efficient to drop close to the source. So you make all the sampling decision, all the data enrichment, and collect all of them and then send it upstream, right? So that's handled by your tracing pipeline. So like this is one example of tracing pipeline. In this example, what you see is that robot-looking thing is Grafana agent, and there is a service. These are 3 services, and they are pushing spans to the agent. And line indicates that this is the infrastructure boundary. So all this is running in your infrastructure, and then agent will collect all the spans, batch them, and then push it to whatever tracing backend that you are using. Like Grafana agent can push to any tracing backend that you are using. Doesn't have to be Grafana specific stuff. You can push to any OTel compatible Jaeger Zipkin through Grafana agent. And then you obviously query it, right? So the third step is you are collecting it, you are batching it, you're sending it, but you need a place to to receive that, right, and store it. So to store, you need a tracing store. So there are three popular open source tracing store database, whatever you want to call it, are there. Top one T is Tempo, obviously built by Grafana and my team. The mascot is Jaeger. It came out of Uber, if I remember correctly. And then there is Zipkin. So you can use any of these to store your traces. And most of these tracing stores have a way to query those traces because you just don't want to collect and store, right? You want to query, you want to ask questions from the data that you have collected. So the first step you want to do is you visualize and query and get value out of your traces, like what's happening when and what. So these three different UIs, this is Grafana. So Tempo doesn't have a UI of its own. You have to use Grafana to query Tempo. Jaeger has its own UI, that's the Jaeger, and then Zipkin has its own UI. So that was tracing basics, you know how to instrument, how to collect, how to ship, how to store, how to query. And now there is another important question, right? Like, when do you need distributed tracing? When should you reach out to tracing and think about should I do tracing or not? One of the question is, like, there is the word distributed, right? So distributed means that it's better suited for applications or like when you have multiple applications, right? And tracing will give you better value if majority of your services are instrumented. Like if you are looking to profile or like get value out of your, let's say you have 6 services, 2 of them are rarely called. There are 4 services that are called and are part of your critical path. So you'll get best value out of tracing when you instrument all 4 of your application and start shipping traces, right? If you instrument one service that is accepting user request, then you don't know what's going on down there, right? Because there are no spans, there is no information about it. So you'll feel like, oh, I did instrument my application, what is happening? So it has to be across services. More services you instrument, better your traces will be, more richer your traces will be, and more value you'll be able to, get from your traces. Another thing is, again, it is distributed tracing. Nobody is stopping you from, instrumenting monolith application, something like a Rails app. But there you will not have cross-service information. Most of your value will be like, all of your spans will be from single services. You can instrument your application to instrument database calls, cache, external services, and you will get value from it. But then it will be tracing, not distributed tracing. I mean, again, words, but you can do it, but the better it is when you instrument multiple services that are critical to you, and all of them are pushing spans to single place. So let's look at how to do an opinionated Grafana stack setup. So you can use agent as a collector, Tempo as a storage, and Grafana as a visualization layer. And instrumentation, obviously, you will instrument your application step 1. So step 2, step 3, and step 4. So this is one example of your setup. Instrument your application using instrumentation library. There are many instrumentation libraries. There is one from OpenTelemetry. That's the popular and recommended way. There is a Jaeger library that is deprecated, and then there is OpenTracing that is also deprecated in favor of OpenTelemetry. And then there is Zipkin client library. But most people instrument, like if you are instrumenting your application today, I would say look at OpenTelemetry. Because OpenTelemetry is the widely supported. So if you instrument your application with OpenTelemetry, majority of the tracing vendors will be able to collect and ship and store your traces. So you don't need to instrument your application again and again, depending on who do you choose to use in the step 3 and step 4 and step 2, basically. So in this scenario, you instrument your application with an instrumentation library. You set up Grafana agent to collect your spans, and then you can use open source Tempo. So Tempo is open source. You can just download it from GitHub, use it, run it on your own, no strings attached. If it fails, do create a GitHub issue. I'll look at it and hopefully help you fix. Uh, then obviously the Grafana is the query like method. Another one is, let's say if you are in an industry where you are afraid of open source software. There are many industries where folks don't like open source software because of compliance overhead that comes with using an open source software. You can use our enterprise traces stuff. Again, same stuff, different binary, everything else stays same. Another one is, let's say you don't want to run it yourself. So you can just leave step 3 and step 4 to us and use our managed thingy. You just instrument your application, install the agent on your infrastructure, collect and then ship those traces to Grafana Cloud. So these are the 3 ways you can do tracing with Grafana stack, depending on what your need is. And if you just want to play around, start with OSS or our free tier, whatever works for you. So let's say you want to do, like I talked about that this talk is about open source. So how can you run Tempo in your infrastructure? So there are 2 ways to run Tempo. One is called scalable single binary. So Tempo is a distributed system in itself, but not everybody needs that distributed system scale. If you have small trace volume and you want to do a POC with it, you don't want to spend time setting up a distributed system and figuring out how to configure, how to tune it, and like deal with all the problems that comes with running a distributed system. So you can just download the binary, run it on your EC2 VM, and give it an address of an object store. Anything that is S3 compatible, so we support MinIO, S3, GCS, Azure, or any other object store that speaks S3 compatible API. So what Tempo does, so you see there are 5 components in the Tempo. There is query frontend, querier, distributor, ingester, and compactor. So these will then write your trace data to a long-term storage that will be an object store. Let's say you scaled beyond your single binary, or maybe you're a big organization and you actually want to run it in a distributed manner. You can run it in a fully distributed mode where each component is running as its own service. And query frontend and querier is your read path, and distributor and ingester is your write path. And they will need an object store, obviously. Like in both cases, and you can go from single binary to distributed mode actually, because your data is an object store. You see there is object store, there's object store. You can use the same data that you already have and just start with single binary and then go to distributed mode, if you need to scale out. So you don't need to, I'll need to scale in future, so I'll spend time setting distributed mode. So your data will still be in the same bucket. You can point distributed Tempo to the same bucket and it'll be able to read your traces. Now there is another big release that is coming of Tempo, that is Tempo 2.0. We are working hard on it. It's coming soon. I don't have a date in mind. We're squashing bugs. But there are 2 big features that are coming in Tempo 2.0. One of them is TraceQL. So raise your hand if you have used PromQL before. Okay, a lot of people. Raise your hand if you like PromQL. Okay, not a lot of hands. This one didn't work out. So TraceQL, like if you know PromQL, it's like PromQL but for traces. You will be able to query your traces in a PromQL-like query language. And the reason we built this is because if we look back to the slide where I showed you the visualization from 3 different sources, all of them were showing a single trace. And we believe that single trace is not very valuable, right? When you're trying to debug something. The value is in the pattern, and that pattern lies across traces, across services. So you should be able to ask questions in a friendly language that goes across your traces and returns answers. Something like, show me spans that started from service A to service B but returned 500, right? You should be able to ask that because your tracing data already has that information. And right now, there is no easy way to ask that question. So that's why we built TraceQL. Another big feature is Parquet. So before Parquet, the internal storage format of tracing data in Tempo was not open. I mean, it was open on GitHub. It's an open source project, but it was not in an open standard. It was our own format, the way we were storing traces. And we realized that, that doesn't scale really well when you want to provide a language like TraceQL. So we re-architectured our storage to write Parquet, basically. So all of your tracing data is now Parquet files, and Parquet is columnar, helps out in the search. Another big reason we chose Parquet is because Parquet is an open standards format. So let's say you're using Tempo today, and you're putting all of your data in an S3 bucket. And tomorrow, let's say there is a question that you want to ask to that data, and TraceQL doesn't support that question. So you can use any other tool that can read Parquet files from your object store and ask any question that you want to ask or any analysis that you want to do. Like you're not tied to Tempo anymore. Your data is in an open format. You don't need to do any conversion. You can ask questions as is, and we feel like this is in the spirit of open source. Everything is open, including the backend data that you wrote. Tempo 2.0 is coming soon. We will publish a blog when it's live. I have a demo that I want to do. It's a live demo. The demo is from like main branch, pushed merged yesterday, day before yesterday kind of scenario. So might crash when we're doing a live demo. So stay with me. If you want to run that demo locally, you can go to grafana.com/intro to MLT, and you will be able to see all the code and the configuration that I'm using for the demo. Okay, let's see. Let's all pray to demo gods. So Docker Compose up. So it's starting local Grafana agent, local Prometheus, local Loki, and a Grafana. And then one service that writes data to a message queue. And there is obviously a database involved. So I'm running all of them locally. See, it's doing things. Let's load up local Grafana. And then there's a pre-built dashboard. So it works, yeah. So you're seeing that data is flowing in. Metrics are coming in. You can see logs are coming in, and you can see this is a graph of 90% latencies. These are latencies across your endpoints, and these are your slowest endpoints, and you can see the slowest one is 41 millisecond. I mean, everything is running locally. So one thing that we can do right now is, you can think of like most APM products have a screen like this that is fixed. You can't change it. In case of Grafana stack, you can change it because it's just a dashboard. You can move it around, add more panels, rearrange, show whatever you want to see. So let's see, we want to see why, where this time is spent. So I can jump from this panel to a trace. So this did a traditional search query where it's showing that, like this is the target service, show me the method, and we can basically filter something that is taking more than 30 millisecond, we can do a search. So this search exists today, like it's available in Tempo right now. And here you see there is this small panel called TraceQL. TraceQL is still new. I'm running again tip main. Look at this doc to see what is the syntax. But let's ask a question that show me the traces that are taking more than 100 millisecond. Like end-to-end operation more than 100 millisecond. So we got few traces that are taking more than 100 millisecond. We found a bug actually. Ignore that. So you see it shows that there is this span that is taking 144 milliseconds, and that span belongs to this trace. We can just click and jump to that directly. Now I want to open it in a big screen. Yeah. So you got the trace, right? Let's say, we want to ask a better question. Like I don't care about all the requests that are slow. I only care about requests that are slow from this service, for example, like request, right? So you can do an AND operation. We're saying, show me the traces that are taking more than 100 millisecond where service name is this, right? And now you can see service name is the one that we filtered on, right? Now let's say you care about a specific endpoint. So let's say you care about this endpoint and you want to know, show me the traces that are slower, belong to this service, and endpoint is this, right? Turns out there are no traces. I guess this service is fast. And one thing that you notice that I'm doing a greater than operation here, right? So I'm saying duration greater than 100 millisecond. And then I'm doing a string filter. So all this is happening because TraceQL knows the type of the labels, right? So it knows what a duration is. So you can do something like http dot status code greater than 200, greater than equal to 200. Let's do. So we get something. Oh, didn't work. Again, this is tip of main. Now I'm doing this demo for the first time. I do have a video as a backup. So I'll show you that. So this is a full demo of TraceQL. Again, like more data and more stable one. So here what we are doing is we are saying, okay, return spans and traces that have HTTP status code 200 and greater and less than 300, right? So this will show you traces that has spans with response code 204 or something like that, right? So we directly jumped to a span, right? So showing you that, okay, this is the span that you're interested in. So now last time we did AND operation. Here we are doing an OR operation. So you're saying I'm interested in traces where I got 5xx or duration was greater than 100 millisecond, like return where any of these conditions are, fulfilled. Now there is one more query, okay. So now we are looking for DB statements. So now it's doing a regex filtering. So it's showing show me insert statements. And now you can do an AND operation with duration also. So show me insert statements that are slower than, 100 millisecond, 1 second, whatever your threshold is. And it'll show you all the traces. So you can like filter it out, see directly. So this another thing is, you must have used functions in PromQL, right? We're building the same thing, TraceQL as well. So now you can run count, sum, average, all these functions, they're not implemented right now, they will come soon. Take my word for it for now. But TraceQL is not just about basic filtering. you'll be able to ask more questions. You'll be able to do more aggregations and get higher level number instead of a list of spans or a list of traces. So this was the demo. One more session that I want to recommend you is like if you want to look at the whole thing, not just tempo and how to do tracing. There is a Grafana Online 2022 session that goes in the whole MLT stack. You can scan this QR code and you will directly go to that session. Okay, and that's all from me. Open for questions.
Hey, hi. Could you please elaborate more on the distributed versus the single node in the tempo?
So the setup,
Not a setup. Basically, I can see there was a read up and write two.
this one, right?
Yeah.
So you can run tempo in two modes, right? Let's say you want to start small, you want to do a POC or you don't have that many traces. You don't want to set up a fully distributed system, right? So you can just spin up an EC2 instance in S3 bucket and have this setup. Okay. And here you see, right, like I'm showing 4 copies of it. So you don't have to have it in single node, right? You can have 5 VMs. All VMs are running all components. You don't have to think about, how many queryers I need, how many distributors I need,
So more of a whole thing as a in scaling. So
yeah.
second question would be like how I'm gonna scale if there's a high log ingestion or trace ingestion.
It's called simple scalable binary. The reason is because you can start with single node, add one more node, run the same binary, and you get double the capacity, right? You don't have to think about individual component. You don't have to think about what is my read path, what is my write path. Just throw a binary on a VM. You need more capacity, throw the same binary on one more VM and connect them together. And distributed system is mode is when so this mode is inefficient, right?
Right.
The reason it's inefficient is because all the nodes are doing all the work, right? Let's say you have an ingestion heavy workload and you're not querying as much. Most of your work on your node is done by ingester and distributor. But if you have a bigger setup and you don't want to waste resources, you want a fully distributed setup, then you can run this, right? So let's say you have an ingestion heavy workload, you can run 10 distributor and 10 ingester. You're rarely querying, so you can run 2 query front end and 2 queryers.
Okay.
Right?
Okay.
Does that answer?
Yeah. Yeah.
Okay.
One more question, does trace SQL support this regex pattern also?
Yes, you can do regex search. If you remember, in the video, we searched on db.statement, regex insert dot star, right?
Okay.
Yeah.
Thank you.
Might not be implemented in 2.0 fully, might be available after that.
Sure.
You're working hard, small team.
I have a question with adding TraceQL, did you see any discernible performance benefits over PromQL?
So PromQL is for Prometheus metrics, right? It's a whole new language. It's not PromQL. So we wrote a different language that allows you to, it is inspired from PromQL. That's why I said it's PromQL-like, but it is not PromQL.
I'm not very familiar with the internals of how it works. I just used it, let's say somebody deployed for me and I sort of went over Prometheus and stuff, but I think there is no performance difference.
Yeah, I mean, these are 2 different systems, 2 different languages, no correlation with each other than the syntax inspiration.
So those DB statements that you filtered, were those logged by, were the DB statements, hand-coded in the code to be sent to the collector or does the instrumentation library automatically captures them somehow?
It depends on what language you're using. So let's say you have your code base in Rails, right? And you're using OTel, and OTel has, and you're using Postgres. Let's say OTel has Rails plus Postgres on auto instrumentation. Then the instrumentation library will attach those labels for you. And if you're using a language that doesn't have that, then you will have to instrument your applications. So you'll have to add that instrumentation.
So does OpenTelemetry does that for us automatically?
Again, depends on the language, framework, SDK. There's a whole big, like list, depending on which version you're using and whatnot.
Thanks.
It's more of, like language dependent thing. You can always manually instrument if your language doesn't support.
So can I get this data programmatically, like whatever, like I need to know which are the requests, like number of requests that are like status code 400, or like the, let's say, the service that is taking more than 400 milliseconds of time. Like I may not be going to the TraceQL and then querying. I want this data to be like, I need to get it programmatically so that maybe I can generate some alerts, or maybe I can, let's say, find some issue with my microservice since my trace is telling like it is taking so long time. Maybe I need to restart my microservice, or some action I need to take. So can I get this data programmatically?
So you want to alert on TraceQL queries. Is that the question?
Yes, alert is one thing. So if I can, let's say, like I need to restart, as I told, like if it is taking more than, let's say, 1 second, like I need to analyze that and then maybe take a decision, like I need to restart my microservice. As simple as that, maybe.
Yeah, I mean, Tempo has a /search endpoint. You can do a HTTP get to it.
Endpoint
and
is there,
you will
okay.
get a response.
Oh, okay,
so
that's
Grafana is just a convenient UI on top of it. The API is documented in our GitHub repo, github.com/tempo. And grafana.com, github.com/grafana/tempo.
Okay, but then alerting is like a different one, or maybe it's making use of
Yeah,
Prometheus.
alerting, I mean, we are busy building the backend and like busy building the foundation first.
Okay.
So we'll think about second floor after we are done with foundation.
Okay, yeah.
Could you please elaborate a bit more on auto instrumentation?
So auto instrumentation it's a language framework, and like whatever instrumentation library you're using is kind of thing, right? So if you're using something like Ruby, there the language allows you to automatically intercept and generate those spans for you.
What kind of limitation does it have, and that like I myself instrument my app that brings in?
So this depends on the language and the library, right? So OTel, like if you go to OpenTelemetry website, they will have list of all the instrumentation libraries that they have for different languages, and what they instrument, like which parts of your applications are automatically instrumented, which parts are not, what they support, and how you configure that library. So it's more of an application plus instrumentation library kind of thing. And it depends on the language also, right? If you have C++ code, probably not be auto-instrumented. If you have Java, I am pretty sure it will be auto-instrumented. Most common parts, like if you're using something like Spring, and OTel has a Spring support, then most common Spring things will be auto-instrumented for you. Same goes for Rails plus Postgres, right? So if OTel library that you're using has a support for Rails and Postgres, then it will try to do auto-instrumentation as much as it can. Thank you, folks.